In my last video, I showed you how to create transects, STP points along transects. And I'm going to show you now how to use the Fishnet method, where we're going to use a Fishnet tool to create a grid. It's going to be a north-south oriented grid. It works well for proposal purposes. It's fast. It's also good for phase 2 studies, since those require northing and easting, so you want all your STPs for phase 2s to be in a north, south, east, west direction. So let's get to it. So the very first thing that we'll have to do is go into Analysis, go to Tools, and we're going to look for, here I have it here. If you don't see it already, you can just type Fishnet, and we're going to create a Fishnet. We need to name the output feature class. In this case, let's call it Fishnet APE 2. Since we already did an APE down here, this will be the second one. This is going to be using a Fishnet. For the origin, there's a few ways that you can do it. You could use the visible extent, so the current display extent, so it'll do everything that you can see here. Or you can pick a layer, and you can use the extent of the layer. We only want this particular area to have it. So I'm going to go into Edit, Select, and right now we don't have this as a selectable layer, so we're going to make it the only selectable layer. There we go. So now we've selected it. We're going to go into this, and this is the LOD. They're both LOD. You can select all features, and then you can select selected features. So we're going to go ahead and pick the selected features. And it's in the WGS 1984 Web Mercator Auxiliary Sphere Coordinate System. We use that because it works well when we upload points into ArcGIS Online. We then have to come up with either number of rows, number of columns, or cell size and cell width, or width and height. For our purposes, we want to have 15-meter grid. So each STP should be separated by 15 meters. So that means that the grid should be a 15-meter width and a 15-meter height. You can see it gets rid of the number of columns, etc. once you put that information in. You can pick either one in terms of geometry type. It can be polyline or polygon. In my experience, it doesn't really matter for our purposes here. It might be nice to use the polygon. I'm going to go ahead and pick it. The difference is that your grid shows up as lines versus polygons. And we're going to go ahead and hit run. And it created our fishnet. You can see, since it's an extent, it's just a rectangle. So we don't need all of the points. We only need some of them. We only need the ones within our APE, which is coincident with our limits of disturbance at our LOD. So we're going to use the Select Layer by Location tool, which I already have it here. If you don't see it, you can just start typing Select Layer by Location. And the input feature, so what we want to actually select. There's actually two different feature classes. We want to use the labels and the polygons, which is the Fishnet APE2. So the Fishnet APE2 labels and Fishnet APE2 area. In this case, I found the best relationship. You can use a lot of them. You can pick intersecting, in which case we'll just go ahead and leave it there just so you can see what it does. The selecting feature, we want it to be the LOD. And it's only going to use the one selected record. You could change that so it selects everything regardless. So it would also select over here. We don't have any points over there, so it wouldn't matter. Search distance, so you can kind of add a buffer around it to where it would select if it's within 1 meter of the LOD, or maybe it's 10 meters within the LOD. We'll see what that gives us. Alright, so you can see it selected everything. Let's see, if we take out that buffer, you can see it selected outside of the LOD a little ways. So let's take out that buffer. We'll put 0 meters. It'll probably narrow the scope a little bit. Okay. And you can see it still has some that are outside, where the points, anyways, are outside. This is actually not that bad. So it keeps all of the features, all of the points, but we want to use the inverse of this because we want to be able to delete. So we're going to select what records to delete rather than records to keep. So we're going to invert the selection. Let's run that. Alright, and that looks pretty good. I think it excluded everything we want to exclude. Let's see. So get rid of these. Yeah, it looks pretty good. You could also use other relationships. You could use within. Let's see what that one does. So that one selects some of the areas that are close to the edge and still keeps all of the points that we would use as STPs. So within probably would have worked as well. You could also have their center within. And that maybe works a little bit better for selecting the correct polygons. If their center is in, so if you're going to have an STP, it picked it. It's probably the same number of points as the intersect tool. I kind of like the intersect best, so I'm going to go with that one. Only because then it keeps the polygons. We're going to really use them. And then we're going to go ahead and open the attribute tables. And we're going to delete the points that are outside of our work area. And then we're going to go into this attribute table. And we are going to go delete all of the polygons that are outside of our work area. Alright. And there we go. So now we have a nice LOD. We have all of our points created for STPs within that LOD. They're all north-south oriented. Let's see. Does that one looks like it does. It falls outside of the LOD. So there's a couple that maybe we can still get rid of at the very edge. So maybe the intersect was not the best. We maybe should have had their centers within. In any case, you can manually delete those. It's not too hard. We're going to go ahead from here, and we want to now name these transects and STP points. I'm going to just go ahead and hit save. We're not going to really use the actual polygons at this point. We're going to add some attributes, since the tool only creates numbered STPs. So we first need to know a transect, and this is going to be a text. We use alphanumeric coding for our transects when we do phase ones. So you have transect A, B, C, D, etc. And that should be a text. And then we have an STP number, and we're going to have that be a short. And we'll save that. And then when we go into the attribute table, now you can see there are columns for transect and STP. They're empty, so we need to start populating them. You could go through and manually enter them. You can use the select, and you can right-click the point and go into attributes here, and I could say that's going to be A1. There you go. Now it's attributed. We know that that's the correct point, but it's going to take forever. We have 964, or how many do we have? 958 points created that way. So not the best. It's going to take a while. So a quicker way to do it is to select the points that you want. Obviously, we don't want to be selecting the LOD when we do that. So we can hit clear. A couple things you could do is turn off the LOD, and then it will only select the points that you want. Another way of doing it would be to right-click the STP points and go to selection and make that the only selectable layer. That way you can select entire rows and it's only going to select STP points for you. Let's see if we can find, I guess, yeah, there they are, all the way at the bottom. So we are going to calculate our transect and STP values. It'll greatly speed up labeling or naming each STP. Let's see. So we're going to start with the transect. You can't have anything in here. This is from the previous time I used the tool. So you want to first select transect. Transect equals should show up here. And you would think that, just putting A, and if I hit the check, it'll tell you it's a valid expression. But if I try to apply it, it's going to give you an error. When you're using Python here, maybe some of the other ones would maybe do it differently, like maybe Arcade. No, that gives you the error. And maybe it was Visual Basic. No, that one says it's valid. So you could try that. Let's see what happens. Let's scroll all the way to the bottom. And although it seemed to be successful, it didn't label anything. So instead, we're going to go back to Python. To avoid the error, you just need to make sure you use quotes. And you'll see that's a valid expression, and we're going to hit apply. And you can see now the transect is properly labeled with the right transect. After that, we're going to go into the STP. We want these to be a sequential number. So now you have STP equals here. We're going to delete the A, and then we're going to go into this filter or helpers. We're going to go to the functions and double click sequential number, and it puts the code to do sequential numbers for the STP. We're going to hit apply. You can see it numbered, and it only numbered for the selection. So we're going to keep doing that by selecting the transects and doing the same process. So this will be transect B. Since we already have STP filled out, it's already got the sequential number, and I've now got the correct areas selected. I'm just going to go ahead and hit apply because it'll be quicker. But I still need to do the transect name. So then we'll go to transect, and then we have to delete here, delete here, quotes, B, close quotes, and hit OK. Alright. And we're just going to keep repeating that process all the way to the very end. Instead of B, it's going to be C. And STP. Oops. STP equals apply. have the right ones done there. Go to transect. D. No code. Y. And so on and so on. So you can see that will probably only take, I don't know, 10-15 minutes, and you'll have everything properly labeled. So that's a good way of doing this. You might have a slightly different number of STPs compared to the previous method of creating transects. This might make more sense in the field to follow an alignment that just kind of goes parallel to the road, or parallel to a property line, parallel to your workspace. This one's north, south, east, west grid, so it works well for phase 2s. It also works well if you're using a compass, even though true north is going to have some magnetic deviation. True north is different from magnetic north. So you'd have to adjust in the field, but you can kind of use a compass to navigate from point to point. We use Esri field maps to be able to navigate from point to point. We have Trimble DA2 units with Catalyst 60 that gets us really close to the point locations. It works well either way, but if you are using the old school compass way, the north, south, east, west might be a little bit easier to navigate from point to point. Whatever works best for you, either way, it does a good job of laying out our study areas for phase 1 investigations, or phase 2 in this case. And in the next video, I'm going to show you how to do a slope analysis to eliminate some of the points that you might have within your APE. Areas over 15% slope do not require STPs, or areas that were previously disturbed. So if we have a way of identifying steep slopes or identifying disturbed areas, we want to exclude those. So that'll be my next video. Thanks for watching, and we'll talk to you later.